Ben Wiegand back here. It is April 19th, 2018, doing the checkoff for Lab 3, entitled BJT Properties for EE3130. So I guess we'll get right to it. We've got our device attached to the test mechanism. Again, this is a Fairchild 2N3904. The base of this BJT is connected to channel 1. The collector is connected to channel 4, and the emitter is connected to channel 2. Again, kind of like the other scenarios here, we've got our channel 1 of our Agilent B2902A device attached to across pins 1 and pin 2. And really what that's doing is controlling either the voltage or the current from the base to the emitter. Basically, so you can set one and then set a max for the other. You got the same thing going on from channel 2 here. You've got your high voltage on pin 4 and your low voltage on pin 3, and you got a similar ground across 2 and 3. So what you're controlling here is your collector to emitter voltage or current on that side. So I guess we'll get right to it. We're looking to sweep our collector to emitter voltage from 0 to 5 volts as the lab says, and then test that at different base currents. So really channel 1 is where you can set your parameters for your base, your constant base current. So here I've got it set for 1 milliamp. And then just a compliance of 1 volt. 6 is the max here, so 1 appears to be well within range, and again that's what the lab kind of mentions to start at. So we will start there. I'll take a look at channel 2, and that's our linear sweep from 0 to 5 volts at 101 steps. And I've got the compliance, or the limit compliance, set to 0.2 amps, 200 milliamps, as the data sheet shows. I apologize, I'm not on the right page here. Shows that our max collector current continuous is 200 milliamps. Kind of zoom in there. So that would be why we chose that value. So now what we can do is we can set up the sweep, trigger it. Again, what we're doing is we're setting a constant current here into the base and sweeping the voltage across the collector emitter so that we develop that swept profile. So we'll hit trigger, auto scale it. You can kind of see that curve that's got your collector emitter voltage on the bottom, and then your collector current on the y-axis. So similar thing as the previous labs. Really what we do here is vary that over different base currents and try a couple different scenarios there to develop the curves that we have on the data sheet. Did forget the USB. Did forget the zip drive for this one. Was not able to get the measurement software to work the way I'd like to after trying for a while. So we'll be running this at a later date. We can make it back to campus, collect all that data, and have the lab report then for next week. So similar type of testing will be going on, kind of iterated multiple different times for various base currents. Again, this is Ben Wiegand, EE3130, lab number 3, BJT properties. Thank you. Have a nice night.